Okay, in this video I'm going to show how to use GRETL to replicate equations from chapter 10 of Stock and Watson. So the first thing we do is open up the data set. The first equation I want to replicate is equation 10.2, where we're regressing the fatality rate on the beer tax using only 1982 data. So I need to select the sample. I set year equals 1982. You can see that we now have 48 observations. We'll estimate by ordinary least squares. The dependent variable is the fatality rate. The explanatory variable is the beer tax, and we use robust standard errors. And here we have the results. And if you compare this to equation 10.2 in Stock and Watson, you see that the results are the same. If we make a graph of the results, we obtain this figure here, and this is the same as what you see in the first panel of figure 10.1. Okay. Restore the sample to the full range. Now I'm going to replicate what we see in equation 10.8. Okay, this is where we're going to regress the difference in the fatality rate between 1988 and 1982 on the difference in the beer tax between 1988 and 1982. For this, we need to create lags of the two variables. We're going to create 6 lags, okay, because from 88 to 82 is 87, 86, 85, 84, 83, 82, which is 6 lags. Okay, so now I have lags of the fatality rate, and I need to do the same for the beer tax. 6 lags. And now I can estimate the model. I'm sorry, I need to create the variables. Add new variable, delta FR for fatality rate equals the fatality rate minus the 6th lag of the fatality rate. Okay, we need to make sure that GRETL doesn't quite get this right, so we need to type it in correctly using _6, which is the 6th lag, as we see in variable 18 there. Okay, I'm ready to create that variable. And now I do the same for beer tax. I'm going to create the add new variable, delta beer equals beer tax minus beer tax 6. Okay, so we've defined the two new variables. Now we can estimate by ordinary least squares. Delta fatality rate is the dependent variable, and delta beer is the explanatory variable. Robust standard errors. These are the results, and you'll see that these are the same results as appear in equation 10.8 of the Stock and Watson book. And if we make a plot of the results, this is what we see, and that coincides with figure 10.2 in the Stock and Watson book. And finally, the last thing we want to do is to see how to do a fixed effects panel data regression. Okay, we're going to go to Panel, Fixed Effects. The dependent variable is fatality rate. The explanatory variable is beer tax. We're going to include fixed effects for states and use robust standard errors. These are the results that we obtain. And you will see that those results are the same as what is in column 2 of table 10.1 in the Stock and Watson book. Okay? So that's all I wanted to put into this video.